Well, hello everyone, and welcome to ART's head office here in beautiful Bavaria, where we have been based since 1999. In this latest of our series of webinars, we're going to see a really exciting development in the history of ART motion tracking systems, and it's the integration of our highly accurate finger tracking set into Unity. As you'll see, this means that we can reach, touch and get physical feedback using anatomically correct hand models that precisely match the user's own dimensions right inside the Unity application. First of all, though, just a couple of housekeeping points. For the best user experience, can you please pin the screen in Teams so that you stay online and watching us, and also please switch off your microphone and camera. And finally, we'll be delighted to take questions, but please can you let us know in the chat, and then we'll address them all at the end. Okay, now, during the demonstration, we'll be using several other ART tools, which is, if you could run the video, we'll show you now. First of all, we have the optical tracking cameras. Here, we're using a combination of the ART Track 5 camera and the ART Track 6M compact camera, and the two together is a bit like using flood and spotlights to make sure that the tracking coverage is perfect and reaches all possible nooks and crannies. Next, we have the finger tracking set. There we are. It consists of two main parts: the back of hand unit, which tracks the hand itself, and then at the end of the variable length wires, we have the finger thimbles, which are connected, of course, to the base station. And this means we can calibrate the system to precisely replicate the user's finger lengths. And also the position of the LED markers right at the fingertips means that the interaction with virtual objects is extremely accurate. Already on screen here is our FlyStick 2 Plus interactive wand and navigation device. The coloured buttons that you can see are programmed to perform interactive functions within the 3D model, or they can operate software menus in VR toolkit applications. And of course, using the top hat joystick, you can see right on top there, or physically moving the device, this allows us to fly and move around inside the 3D model. Next is the measurement tool. It's a simple tracked pointing device which is used to take accurate measurements either of real-world objects or from inside the virtual world. More on that later. And this is the head target that we'll be using to track the position of the user's head. And using this is what gives the immersive feel to an application. It provides perspective, position, and parallax, especially with when used with stereoscopic displays. Worth noting also at this point that ART makes a wide range of clip-on targets like that for most of the major brands of shutter glasses and head-mounted displays. And finally here we have our switch box demonstrator, which shows the functions of the other tools in action. All will become clear shortly. So let's now have a more detailed look at the finger tracking set. The first thing to do when using finger tracking is to calibrate it for the user's hand size and finger lengths, as ably demonstrated here by my colleague Hanno. We're using the 3-finger version here today, with the remaining 2 fingers being very effectively simulated by using inverse kinematics. However, the finger tracking set is available with all 5 fingers tracked, but we find that most customers do prefer the 3-finger version for convenience. Now, what we're doing here is the calibration for both hands, and it's a 2-stage process. First, we need to register the position of the main unit on the back of the hands, a simple calibration routine where the the unique positions of the LED markers are recognized, and it can be identified as an individual object. And then we perform some simple finger movements to measure the length of the finger joints on both hands. It's worth noting actually that the finger thimbles that you can see here on each of the 3 or 5 fingers come in 3 sizes as standard with all products, small, medium and large. We think it's important that the thimbles fit individual finger sizes precisely so that they don't move around and of course affect the accuracy of the motion capture. And once the calibration process is complete, both hands and fingers will be able to see the representation of the tracked LED finger targets here in the individual D-track camera windows. That makes us certain that all of the data is being captured properly. Okay, now the final step is onto the Unity application itself. As you can see here, what we have is a project that we've created, and we're also running the ART Unity plugin. Shortly you'll see that we've obtained a generic model of a car interior from the asset store. And what we're in the process of doing now is adding the ART tools to the asset window. And that is, just to remind you, the finger tracking set, the head tracker, the FlyStick 2 Plus, the measurement tool, and the demonstration switch box unit. In addition, we'll be allocating the output IP address from the ART tracking system so that we can get the tracking data into Unity and attach correctly to each of these objects. And finally, we add the hand models. These we found from Leap Motion in the asset store. And at the moment, we're just then setting up the finger tracking so that it's overlaid correctly onto the fingers in the 3D hand model. And that's it. When that is complete, we'll have a look at the individual tracked objects working correctly within the 3D model inside Unity. Just a moment longer. And here we are. So Hanno is wearing the finger tracking set, but he's just putting on the head tracker. And you can see when he looks into the scene how his viewer perspective is changing. He's tracking his orientation and position. And let's go through the tracked objects one at a time. We have the back of hand unit in action here. We can see how the hands themselves are being tracked. After all, the hand is quite a complicated thing with wrist movement, hand movement, and finger movement. So the tracking does need to be very accurate to be able to effectively do this. Let's start moving the fingers. Not only are the individual finger joints tracked, but also we have, with our finger tracking set, accurate abduction. That means we can move the fingers apart from each other too. Now, because the finger tracking set also has vibro-tactile force feedback motors, we can get some idea of when we are touching surfaces within the 3D model. We can touch individual fingers together, we can touch our hands together, but also we can interact with other items within the environment. So, for example, we can touch the steering wheel, the rear view mirrors. And one other point to note, which perhaps you're thinking, is that, for example, with leap motion, we can get a very good hand representation. But interestingly, if, for example, as we would do in the real world, we were adjusting the radio in the car, we could be looking out of the window at the same time. We don't have to be looking directly in the area where our fingers are moving. We could be looking completely in the opposite direction because the tracking cameras are outside of the environment. Okay, so this is where it gets a bit confusing. Hanno has picked up the real fly stick 2 Plus, but he's simultaneously interacting with it and the virtual one at the same time. So the buttons can be programmed to perform exactly the same functions or other ones. And of course, if he was running in immersive tracked stereoscopic mode, the real device or the user's hands would be exactly overlaid on the virtual version, so his reach would be the same. And this, of course, is where the accuracy of the finger tracking set is critical. It's the same for the real and virtual switch box, so that the user can precisely operate the collection of switchy switches and twisty knobs, both real and virtual. And you can see here how that would apply very well to training simulation applications, where this could be the interior of a train or a plane or any other piece of expensive or potentially dangerous equipment. Finally then, let's have a look at the measurement tool, where we can take simultaneous measurements of objects both in the real world and in the virtual world, by virtue of the model we see on screen here. It means that, for example, designs can be verified and ready for manufacture. Well, actually, let's take a moment just to consider what is happening outside the scene while this is happening. What we have, of course, is the ART tracking cameras that are performing the necessary real-time orientation and positional measurements to allow all this to happen. The system, of course, as you'd expect, has a native sub-millimeter accuracy, but also equally important is the tracking stability. It's one of the things that ART is very well known for by our major customers. And this means that a calibrated position will be held exactly and will never drift over time. And it means that the simulation and interaction will remain completely accurate from the start to the finish of the session. And this is critical. For example, when overlaying augmented reality graphics onto real-world objects or verifying a computer-aided design against a physical prototype. So there you have it, the fundamental accuracy, stability and adaptability of the ART motion tracking system is now accessible to the Unity development community. And of course, it also continues to be supported by many of the existing major real-time 3D and industrial CAD VR tools. Well, thank you for your attention, ladies and gentlemen. And now I think it would be appropriate to take any questions that you may have. I'll pass you over to my colleagues Klaus and Mitilesh, who will answer those that they can and will gain your contact details and get back to you with responses if we can't. And thank you very much.
I hope now we will hear me. So in this case, we are using 10 cameras.
Yes, but it's a variable. Typically, we'll need probably 6 cameras at least to make sure we cover the full range of movement of the fingers and hand. And then other factors come into play. It could be in a seating buck or on a large projected screen. So the best thing to do is just ask us. We can produce a simulation showing the cameras and the angles, and you'll know exactly what's required after that. We do have a full mocap set. Normally we use a 17-piece set, and it's been designed so that it fits over normal clothing. So it uses individual body segments markers for feet, leg, arms, and body and head. And typically that would need a minimum of 8 cameras to track a relatively small space, let's say 3 by 3 or 4 by 4 meters. And we can then transfer the data directly to our ART human application and then record it for other major mocap analysis applications.
Have you a calibration script where you can use the HTC Vive VR glass with ART hand tracking? So can we use ART hand tracking with HTC Vive?
Create a script? I don't know.
Yeah, script maybe is not the correct word, but what we have is the setup is exactly the same as we've seen here. The only real difference is that instead of just using the basic head tracker, that tracking target is attached to the HTC Vive head-mounted display, and then we can use a means of fusing the data with the inertial measurement unit inside the head-mounted display, so you get best of both worlds. Fast orientations and also very accurate positions.
Okay, Hanno is suggesting LPVR.
Hanno is knows an answer.
I see. Okay.
And then another question is from: are you planning to have a Unity SDK for full body tracking too?
Hey, Claudio. Yes, but there isn't such a thing available today. One step at a time, I think.
Yeah.
Our resources are relatively limited. Finger tracking today, and that will extend to full body motion tracking, especially if our customers tell us that they want it.
So Ramesh Kumar is again asking regarding to his older question that they want to see the full body motion tracking system with CATIA model 3D projector, curved screen ART tracking. So we can show them in particular software, but
Yeah, but if you want to run real time from CATIA, then you probably need to do that via a middleware application, such as TechViz, for example, and then it would be seamless. TechViz has the drivers for all of the ART devices, finger tracking and full body motion capture, and has the ability to run the CATIA models in real time too.
how appropriate is it when compared to XSense?
Appropriate is it when compared to XSense? Well, XSense uses individual inertial measurement units on individual on body parts, and IMUs always have this stability issue with some drift over time. I think there are different tools. Their market, correct me if I'm wrong, is largely in performance motion capture, whereas we've developed a specific set of tools and techniques that we have for industrial virtual reality and visualization. It's an interesting question. The reality is actually in the marketplace, I don't see customers comparing the two products. Normally, when they've done the first evaluation of basic information, then they separate. So if their application is more concerned with, if you want to track 6 people recording a fight for putting into a computer game or a movie, then we don't do that. That would be where our products would separate. But if you want to do detailed tracking in front of a large screen or with head-mounted displays using accurate CAD data, as we've described earlier, then I think ART would be the tool that you should consider. But if you have any questions, in detail about the specifics outside of this session, then please just drop us a line, and we'll be happy to address it in as much detail as we're able to. Okay, it's a long question.
Another question is
Johannes, just squinting here a little.
Not a real question, maybe just as in the inspiration. VR headsets make use of late state reprojection. This basically applies tracking results to the latest rendered images and deform and images just before being displayed. When an input AR finger tracking, this late state repro is also applied to the visual representation of the hand model. And thus the hand will always lagging behind 1 frame behind the actual tracking maybe there is some way to overcome this.
Okay. I think that's one of the ones that we'll need to get back to you later with Johannes, because I haven't experienced or heard of that single frame lag directly. My understanding is using the combination of the IMU and the optical system eliminates that largely, but I could be wrong, so we'll need to tell you for sure. So please let us talk to the development team, if you can make sure we have your contact details, and we'll get back to you about that. Liz, can you make the notes, please?
Okay. Have you updated Unity VTrack plugin package with finger tracking support? I think it's in the GitHub, I guess. So
I think also.
if it is updated, not, I think no good answer.
Yes, is the answer. The whole purpose of today's presentation is to show that the finger tracking support in Unity is available and working, as I hope you saw.
Okay, this send technical information.
Yeah. Right. Okay. Yeah, my colleague Vitalis is nodding here, and he'll take care of that, Ramesh, and you'll be hearing from him soon. Okay, shall we draw proceedings to a close?
Yeah.
Okay. Well, again, thank you very much, everyone. I think it's an exciting development here. Personally, I look forward to learning a lot more about the limits and possibilities using this major tool, and seeing the creative results from the many users that are out there. So thank you for attending, and see you next time.
Okay. Bye bye.
Bye bye.